Okay.
One second, Doctor. One second, Doctor.
Honorable.
One second, Doctor. One second.
Okay. Okay.
You're on with this.
Yes.
Yes.
I'm very good.
So we are getting into the webinar, Professor Meghwal as well as Dr. Samrapani. Very good afternoon to everyone. People who have joined today in this webinar series, the 9th webinar series of 4th day from GRI Center, New Delhi. We have conducted very different subjects, very different speakers, and it is reaching out to all walks of students' life, students' fraternity. That is what the assignment this center has taken as a holistic view. When our chancellor had told that the purpose of this webinar should be enriching students in different walks, different subjects. So we are putting our level best, our efforts to that. I thank sincerely all the speakers, those who have joined us in the past as well as now. This webinar series is truly going international, and I am very, very happy to join you in this morning. As to start immediately, let me have a prefix to this program as in this webinar series when we have started it off. The largest drive of vaccination is going on in our country. This largest vaccination is not only sheer size, the reach. It has been serving to millions of people in this country and worldwide. This is one of the largest vaccination drives. I request all the people those who are seeing to inform their near and dear, and I request once again everyone to please get vaccinated yourself. This, by doing this, you are doing great to your family, yourself, and the country. And secondly, this is very important. In spite of vaccination of both the doses, we should not let our guard down at any given point in time till we are safe. So I request you all to wear masks, be in public places whenever you are there. Please wear masks and never let your guard down. Thank you so much. Now we are getting into our 9th webinar series. Let me request our coordinator and head of department management, Dr. Professor Sandra Pandian, to give a welcome address to this session. Over to you, sir.
Okay. Good afternoon to everyone. I am very happy to welcome each one of you for this 5-day 9th webinar organized by the Gandhigram Rural Institute Center located at Delhi. Our Honorable Chancellor have taken more efforts to spread the or to give the education not only to the GRI campus for the rural students all over the world. So, with the effort of our Chancellor, we are running the GRI Center in order to impart the knowledge, the education and research knowledge to the rural students. So, our Honorable Vice Chancellor recently joined Honorable Vice Chancellor Dr. S. Madheswaran. He is also inspiring us for organizing the various activities. And next, our registrar, VPR, Dr. VPR Kumar, also have involved in each and every activities of our GRI Center. I welcome each one of our administrators, Honorable Chancellor, Vice Chancellor, and the registrar for this program. And the resource person, today, resource person, Dr. Murlidhar, is in the National Institute, the Food Technology. In our department, we are offering BBA and MBA program in Gandhigram Rural Institute. And the Department of Rural Industries and Management. The department is very related to your the institute, we have one separate unit, food processing unit, fruit preservation and food processing unit. We are having lot of experiments and the training to various self-help groups. So the topic as well as the resource person is relevant to our the field. So on behalf of the GRI Center, I extend my heartfelt welcome to the resource person, Dr. Murlidhar. Sir, welcome you, sir. Welcome you. And we extend the heartfelt welcome to our resource person. I have some work there. I will join after some times. And our the technical officer and also the webinar convener, Dr. Krishna Kumar, is taking more efforts and for organizing such activities. Really, I appreciate the efforts taken by our Dr. Krishna Kumar during this pandemic period. We have to contribute anyway to the poor rural background students. So this is the very good effort taken by the ERI Center. I appreciate each one of you for organizing such a webinar, and I welcome on behalf of the my personal behalf and on behalf of the GRI Center. I extend heartfelt welcome to each one of you and the participants. The participants, nearly 9,000 viewers through YouTube. They are also getting more benefit by organizing such webinars. I extend heartfelt welcome to each one of you, and I will join later. Thank you for giving this opportunity. Thank you, thank you,
Thank
thank
you,
you.
Doctor. Thank you, Doctor. Thank you for your
Yes.
valuable time
Okay.
in spite of your busy schedule.
Mm.
Thank you so much, sir.
Okay.
Now, over to the webinar. When we are talking about a webinar, it should be informative. The webinar's topic should be very, very important. It should be knowledgeable, and even more to that is the speakers, those who are doing justice for that the complete work, whatever they have undertaken, is commendable. It's commendable. I'm sure this is going to be a library material for the students, those who are viewing this. I request all the students kindly spread the information, make others also to those who are not known. Please make them aware of this kind of programs. Ask them to uh, uh, come and join us in this webinar series by just endorsing this program quality. I'm sure all of you will do it, and with very very grateful heart, I'm thankful to Dr. Murlidhar Meghwal for joining us in this webinar series. It's a it's a part of my job, you can say, or it's a courtesy I have to extend. Uh, Dr. Murlidhar Meghwal, introduction of Dr. Murlidhar Meghwal. I don't think that he requires an introduction. He himself is a sort of mobile library, what I have heard from uh, your own people, Dr. Murlidhar Meghwal, the students fraternity, those who are associated with you. It's very humble welcome from all of us from GRI Center. This ninth 5-day webinar series, fourth day, is now going to commence. And I'm really thankful to our Chancellor, Dr. K.M. Annamalai, for initiating this kind of program. Our Vice Chancellor, Professor Madhav Shivan, who is wholeheartedly supporting this program, and our Registrar, Dr. V.P. Arshil, who actually gives unconditional support to this kind of thing, which is enriching the students, not only urban students, but also rural students. Now to introduce Dr. Mukher Meghwal. Dr. Meghwal has received his MTech uh, master's degree and PhD from IIT Kharagpur. IIT Kharagpur is very well known institution, and he has authored 6 books, has published 50 research papers, over 50 research papers. His major area of research are cryogenic processing, uh, phytochemicals, packaging, spice, and condiments processing. He is a lifetime member of AFSTI Mysuru, ISAE in Delhi. He is a recipient of several scholarships, fellowships, awards from President of India. He teaches food preservation, novel food processing, transport phenomena, food beverages, dairy technology, flavor technology at UG and PG levels. He is very actively involved in research and teaching. Dr. Murlidhar Meghwal, uh, his area of specialization, you can say, is grinding of spices, food powder and particle engineering, food bioactives and functionality, oil stability, and food flavors. His PhD is in this own subject, food processing engineering, and his MTech is in dairy and food engineering. Sir has held various positions, undoubtedly as assistant professor, as associate professor, and he is a member he is a member and he has received a lot of awards and honors. He is a recipient of President's Award from President of India, lifetime member of Association of Food Scientists and Technologies India, lifetime member of Indian Society of Agricultural Engineers in New Delhi, lifetime member of Nutrition Society of India, National Institute of Nutrition in Hyderabad, fellow for Rural Research Fellow Award from the Ministry of Human Resources Development, Government of India. Uh, he is fellow of Master of Technology from Ministry of Human Resources Development from Government of India. He is a recipient of Foundation for Academic Excellence and Access FAEA of New Delhi and member of Advisory Board of Journal of Food Science and Technology. Then he is qualified graduate aptitude test in engineering GATE. He is a chairperson and board of examiners food technology Jain University Bangalore. He is a member board of examination food science and technology Jain University Bangalore. He is associate editor of International Journal for Food Science and Nutrition. He is associate editor of International Journal of Advanced Engineering and Technology, and is a member of ANH Academy, London, UK. Sir, if I can go on, I can go on introducing. The time is very, very low. So I request you to please come and start the webinar. I welcome you wholeheartedly, sir. Thank you.
Thank you. Thank you very much, Professor S.P. Krishna Kumar, Professor P. Sundar Pandyan, Gandhigram Rural Institute, Ministry of Education, Government of India, GRI Center in New Delhi. I'm very much thankful for giving this opportunity to present the topic in which I have done my PhD and my students PhD also working in this field. So this is grinding of spices. So I will be discussing both novel approach for grinding of spices and traditional or conventional approaches for grinding, and also we will try to understand basic fundamental theories involved in grinding process. So I hope PowerPoint presentation is visible.
Yeah, it's visible, sir. You have to put it in full screen.
Yes,
Yeah.
I have kept it full screen.
Yes, sir. It is now okay. Please go ahead.
Okay, so this is the topic. Cryogenic grinding of spices is a novel approach over traditional grinding techniques. So we will discuss. First, we will try to understand what is the grinding process, what are the different principles involved in this process. Then we will discuss what are the challenges faced in a conventional grinding process. And then we will come to cryogenic grinding approach. So this will be the outline of my presentation. I will be discussing about the food preservation and processing. So as Professor Pandyan and then Professor Krishna Kumar was discussing that in our India, the lot of work the institute is have taken because processing and preservation is very important. In our Indian context, if we compare with the developed countries, we lose lot of fruits, vegetables, and food materials. So the processing is very much important. Then I will be discussing about the conventional grinding, cryogenic grinding system, application benefits and challenges of cryogenic grinding, And then finally I will be showing some of the latest research done in this field. So preservation, processing and retention. So we try to preserve the food. So for preservation there are the several methods. There may be high temperature processes like we do blanching, cooking, pasteurization, sterilization. So those are the high temperature processes. Then there are some low temperature processes like we do cooling, we store at refrigerated temperature or chilling or freezing, or we keep the materials at frozen condition. So these are the temperature based or heat based, low temperature, high temperature food preservation methods. So what is the purpose of processing? Why we do processing of food? So the one aspect of preservation is to extend the shelf life of food materials so that we can keep for longer time. Other aspect is to add the value to the food materials or make it convenient, make it ready raw materials for making further other food materials. So there are several processing methods. It may be milling, it may be grinding, maybe mixing, separation, extraction, expression. So all these are the unit operations we do in food processing. So here we will be discussing mainly about this milling process. So there are different terms they use for milling. We may say grinding, we may say humiliation, we may say size reduction. So these are the different terminologies we use for this grinding process. So grinding is a process of reducing size of solid material by mechanical actions. So we apply some force, mechanical force, so that bigger size materials can be brought into a smaller size, like we have grains. And if we do the grinding of grains and we produce atta or wheat flour, so then we can make chapati or any other bakery products. So bigger size materials is reduced into a smaller size by applying mechanical actions and dividing them into smaller particles. So now this grinding process are of two types. One is for the food materials in which we do grinding and finally our product is dry. So you may say edible flour, maybe spice powder. So their condition is that the moisture content is less than 16%. So this is one type of grinding, dry grinding. Other grinding is wet grinding. So in wet grinding, our final product will be in the form of paste or batter, and moisture content is more than 16%. So here main criteria for classification of grinding is based on the moisture content. So if it is more than 16%, then we say it is wet grinding. So final product may be in the form of paste, batter, or we say coconut paste, which we use in South India, making uh, dosa chutney and all. Now, what is the application of grinding? Perhaps the most extensive application of grinding we find in food industry is the milling of grains to make wheat flour, because we see uh, wheat flour or maybe ragi, maybe bajra, so these or maybe rice. So these are the staple food. Majority of people they consume these kinds of food material. So these food materials need to be milled. So we do milling or grinding. So this is the major sector in food industry. Apart from this, we use grinding process in other sectors also, like we do grinding of corn for manufacturing of corn starch or grinding of sugar. or milling of dried food such as food powder for production of bread, cake, biscuits like we use in bakery industry. Now, the spice grinding. This is a use industry in our food processing. So in our day-to-day life, in every home we use spice in some form or other. So spice grinding is important. Now, before moving further for understanding spice grinding, first we'll try to understand what is the mechanism of grinding. How this we told the definition of grinding very easily, that we do reduce the size of particles from bigger size to small size. But how it is happening? What is the mechanism? So in this grinding, size reduction, this is achieved by fracturing the materials. So for fracturing materials, we need energy. So we apply the force, energy, and with the help of that energy, we do the size reduction. So you might have seen the different grinders, maybe atta chakki. So they apply lot of energy, lot of force. So that is the reason there is a lot of heat generation. For efficient grinding, energy applied to the materials should exceed. So this is the mechanism, that when we apply the force, that force should be more than the what can material bear the maximum force. So we cross that limit, then we are able to correct that materials, and that maybe margin maybe is small possible margin. The minimum energy needed to repair the material, so it should cross over that threshold. So when we apply the energy, material is stressed by the action of mechanical moving parts of the grinders. So we will see different types of grinders. So then you can see how the different parts and different structure do the grinding. Here, time plays an important part in fracturing process. So we have to give the sufficient time for getting the required grinding to be done. So this we will see in hammer mill. So material keep on rotating until it get the required minimum size. Then only they can pass through the sieve. So this energy requirement, this is very important, because here how much energy we are applying, so that directly relate with economy revenue. So our intention, our focus is to reduce the energy consumption, and it also leads or relate with the quality of the material. So if we apply lot of energy, lot of heat generation, more damage to the. So it depends on hardness of the materials. It also depends on the tendency of materials to correct friability.
Please.
I think somebody's mic is on. Kindly mute. So mechanism of grinding, basically we discuss based on the different type of forces acting on the material. So these different forces may be shearing or attrition force. Generally, when we go for this kind of grinder, called generally traditionally we use chakki, atta chakki outside. Then impact force. So this is in hammer mill. Then compression force, like we cut the fruits by with the help of knives and all. Then shearing and impact force we find in pin mill. Then shearing force again is you can see in fruit cutting. Now, what are the different types of grinding equipments we need to get the desired size reduction? So, size reduction equipment we can divide into different classes, because this size reduction process they use in other industries also, like in mining or ore grinding. So they have ores, the big size of rocks, and they want to crush it and make it powder and then further process. So first First type of size reduction equipment is crushers. So major action is compressive force, breaking the large pieces of solid material into small lumps. Second category is grinders. So grinders combine, they use both the shear force and impact force, and their compressive force is also there. And they reduce the feed materials into powder form. So this grinding process is the people use is from ancient time. So we read in Srimad Bhagavatam, a very old ancient scripture. The Lord Krishna has appeared on this earth as per the scripture 5,500 years ago. And there one description comes that when little Krishna, he is God, but he tried to play a role of human being. So then he, like a normal child, he did not lot of mischievous activities, like he break the pot and he distribute butter to all the monkeys and all. So being a mother, Yashoda tried to teach him a moral lesson. So the description comes that Mother Yashoda has tied Lord Krishna to a mortar and pestles. It means we can see that that time also they use for these kinds of devices for size reduction, for grinding. In other scripture also there comes a description where we see that the festival like marriage, ladies comes together, they grind the turmeric. So it means this grinding process people use it from ancient time. But with time, some challenges comes, some problems come. So that we will be discussing here. So first time they used to use these kinds of mortar and pestle devices, which is the simplest one, which have a concavity in a stone, in which we can put the grains, and then we can do pounding with the help of these kinds of hammers. Then with the time, a lot of modern machineries came. Like here, yeah, you can see some of the grinders like colloidal mills, spin mills. So these equipments has been put into different categories, like traditional mill. This is people used to use in home. Then hammer mills, then roller mills, then colloidal mill. This is the colloidal mill. Then fixed head mill, then ball mill. We will be discussing about this ball mill also. Then edge runner mill. Then disc beater mills. So in Ayurvedic medicine preparation, they use several kinds of herbs and all. They may grind it, they make the powder, and then they distribute. So this is one of kind of grinder. Edge runner mill they use, and you can see this powder, spice powder or herbs powder to make the formulations. Then pin mill. So here you can see this is a pin mill. So their pins are there, and both the side pins are there. So one may be in a stationary condition, other may be moving. And while moving with a lot of force, with a high speed, they with the help of force like impact force, grind the materials. So this as we were discussing about the two classes, one category is cursors and other is grinders. So this is example of cursors. So suppose you have big size materials and you want to make fine product. So these kinds of stationary jaw cursors we can use. So you see this side, this is fixed. This is fixed structure. But this structure is moving. This can move like this. So when it comes near to this, it crush the materials. And finally, here you have opening. So here we get fine powder. And then other one is crushing head kind of grinders. So here we have these kinds of this arrangement in which this is kind of rotating head. So, and also this moves backward, forward. So while moving, it crushes the materials, and this with this finer opening we get the fine products. Then comes to gyratory crushers. So still now, if you go to the towns or village sites, people use this kind. So maybe they use with the help now with the help of electricity. Earlier they use some bulls or animals, like they have coconuts and they crush it with the help of these kinds of gyratory crushers, and they'll get oil. So here you can see this coconut oils, and then they keep it, store it, and they use it throughout the year. So this is another kinds of grinder. So this is a hammer mill. So here basically it's have several hammers, set of hammers. You can see these are the hammers. So we feed the materials here. So materials come inside this grind, and these hammers they rotate at very high speed, very high RPM, and during this these are rod like structure, and in center we have these rotors. So when they rotate at high speed, they take the materials, they strike with this wall with the help of hammer, the impact force, and due to that impact force materials break down. And here we have sieving arrangement, sieve. So when materials get broken down in desired particle size, then they can be taken away from the sieve. So this is a hammer mill. So you can see this. This is the feed. Here we have feed, and these are the hammers, and these hammers rotate at very high RPM, and here we have sieve arrangement to grind it. Then we have this circular plate kind of structure. So we feed the materials, and it's kind of having this rotating arrangement. So it grind the materials, and finally we get fine powder. So we can say this is a kind of having axis rotation, and it is having a rotor kind arrangement, and that rotate, and along with that hammers rotate at high speed. So it is kind of, we say, plate mills. You can see this one plate, this another plate. Then comes to the roller mills. So in the roller mills we have rolls. So you can see these are the rolls, two rolls, and these rolls moves in this direction, and what are the materials come in between, they crush it. The same kind of rollers we also use for in paddy processing or rice milling industry. So rice have husk. So first we do its parboiling, or maybe normal rice also we take, and then we feed the materials. Then this rotor runs. Then they will lose the husk. So then we can easily remove this. These kinds of roller here you see, this we use in flour mills. So these roll kinds of structure, and these kinds of corrugated structures are there. So when these materials come in between those rolls, it will crush it and make its powder. So if you visit the milling industry, you will see there are several these kinds of sets are there. So they do grinding, and based on the size, they get maida, and then atta, then dalia, then bran, all kinds of materials they produce. Both the rollers rotate at same speed. So they rotate with same speed, and they compress the materials. This compression is primary force to get the final materials into smaller size. And if we set different speed, then shearing and compression force will take place. So these are the primary forces for doing the size reduction or loosening the husk. If rolls are grooved, so like this kind of structure, grooves are then tearing and grinding it takes place. The coarse grooves provide less size reduction than finer grooves. So if we put these grooves, if you see, so if these grooves are very fine, then we can get very fine powder. Here also you can see in starting bigger size grooves, and then it's coming finer size grooves. So when we reduce the groove size, we get finer and finer size particles. Now we want to discuss about the ball mill. We have discussed earlier that in grinder ball mill also we use. So these are the driving rolls. This drives this mill, and we use stocks. So these are the stocks, or these are the balls. So these stock materials, maybe we want to do the size reduction, and this outside we have container in which we contain the materials, balls, everything. Now when we these driving rolls rotates, then this grinder start rotating like this in this direction. When it rotate, so these balls also rotate, and they rise to up to a certain height, and then they fall down. So when they fall down on the materials with force, with impact and compression, they grind the materials. So these balls will do the size reduction. Now, in this grinding process, when we increase this speed, so if it reaches a particular speed, then we see these balls will also start rotating along with this container. So this is the first case, is static conditions. Slowly we increase the speed, then the balls start rotating. Here they start falling, and we have increased speed more. So some balls falling, some balls are rotating along, and in a particular condition, all the balls start rotating along with the grinder only. There no ball is falling. It means there is no grinding. So this condition in which all balls start rotating along with the container, we call critical speed. So we have to avoid this critical speed, otherwise we will not get size reduction, and we will be keep putting the energy and grinder will be running. So we have to avoid this critical speed. So to calculate critical speed, they have done the estimations, calculation, determination. So the 76.63 divided by under root d. So this is the formula to calculate the critical speed. So d is the inside a mill diameter in feet. It's based on the how much is the diameter. Accordingly, you have to set the speed. CS is critical speed in a revolving per minute. So we have to avoid this critical speed to get the size reduction. Now, this conventional grinding, it have several drawbacks and challenges. So when we do the grinding, there is a lot of heat generation. For example, when we go outside to Chucky, attrition mill, we get our powder or spice ground, we bring it, so we can feel how much heat it is. It's become very quite hot, high temperature, quite high temperature, like 90 degree. And at that high temperature, it loses its quality. The introduction of tensile residue stress, so this they generate in the food materials. There is a less tool life. So if you see, if you go to the industry, you will find these kinds of the tools, they run for some time, then they have to remove it and they have to pull. So due to high heat generation, the shelf life get reduced. Then oxidation. So gases like oxygen is there in atmosphere. It's get the when we do grinding, then we break the materials inside constitutes comes out. It react with oxygen, and at high temperature, oxidation become faster. So this is another problem. Then clogging and gumming of the mills. So when we do grinding, so some of the spices they have lot of oils. So particularly if we take ajwain, so ajwain have a lot of volatile oils, and when we try to grind, so that oil will come out, and when it generates lot of heat, so that due to heat generation, this oil will melt and it will clog the mills. Lot of oil generation, releasing and then clogging mills. Then we cannot do further grinding. Then loss of volatile oil. So spices, phytochemicals, they have a lot of useful health benefiting compounds, and due to this high heat generation, these useful compounds get deteriorated, oxidized, the loss to the spice or our food commodity, it lose its value. So how to overcome this problem? these kinds of problem, as we discussed, that high heat generation, tensile residual stress generation, less tool life, oxidation, clogging, gumming, the volatile oil less, discoloration, color also get changed in material. So to overcome these problems, we come up with cryogenic grinding of spices. So this is the cryogenic grinding system developed by Professor Tridip Kumar Goswami at IIT Kharagpur and Dr. K.K. Singh, the director of CAE Bhopal. So they have worked on it and they have developed this cryogenic grinding system. So we will try to understand what is the cryogenic grinding system. Before that, we will discuss some of the fundamentals, things which is required to understand the cryogenic grinding process. So first of all, this word cryogenics, what it indicates. So this cryogenic words, this originate from a Greek word cryo, which means creation or production by means of cold. So these cryo words deal with cold. So cryogenic branch particularly deals with low temperature process. So it deals with low temperature process. How much low? It may be as low as minus 150 degrees Celsius or minus 196 degrees Celsius. Cryogenic is a study of low temperature and behavior of materials under these low temperatures conditions. Because we use this approach in several industries. For example, rubber industry. For example, in aerospace industry. Similarly, in medical field. So that is why it's very important, and we have separate department for this science, these disciplines. Like in IIT Kharagpur, we have this department of cryogenic. So there are all kinds of this process we read in details. A person, you study the element they have been subjected to extremely cold temperature is called cryogenicist. So the person who work in this field is expert in this field is cryogenicist. So this is liquid nitrogen. You can see this is a pouring on materials. So nitrogen, we will be discussing here why we use nitrogen and why it is so important. So there are several cryogenic liquids we can use. Nitrogen is one of them. We can use helium, neon, argon, krypton, hydrogen, methane, or liquefied natural gas, or maybe more. So here most important is liquid nitrogen we use. Commonly we use this one. Why we use? Because in nature plenty of nitrogen is there. If we compare with helium, very less. If we start helium extraction, it will be very expensive, even though it is also inert gas. Now when we extract and try to store these kinds of gases, so when we compress it, we extract it, it's having a lot of vapor pressure. So the earlier scientists, they have faced the problem for storage. So they have developed certain devices to store these kinds of liquid. So this we call it Divar Flask. So Divar Flask have very good insulation. It's a very good insulation, and different kind of cryogens we can store in it. So these kind of gases we discussed, we can use. So these different cryogen, they become liquid under different condition of temperature and pressure. So each gas, they have its own specific properties. So they at a specific condition of temperature and pressure, they become liquid. But these all the gases, they have property common, that is extremely cold, and there is small amount of liquid can expand into very large volume of the gas. It means if we try to compress them, extract them, they are very cold. But as soon as they get the heat, they try to evaporate. They will try to occupy more and more space. And if we will not able to handle properly, it may lead to serious accident. The extremely low temperatures are produced by using substances called cryogens. So liquid nitrogen, liquid heliums we can use. So all these liquids, cryogenic liquids, are gases at normal temperature and pressures. So these gases must be cooled below the room temperature to liquefy. So we cool them at very low temperature. So then we can cool them. So like liquid nitrogen, it's have boiling point 196 degrees Celsius. So you can imagine how cold we are bringing these materials to the. So nitrogen gas make up a major portion of our atmospheric gases. Like it is 78.03% by volume. And other good thing with liquid nitrogen is that it is inert, it is colorless, it is odorless, it is non-corrosive, it is non-flammable liquid. So these kinds of property help us to use this gas in food. For example, it is colorless, it is inert. So if something we use in food and it gives color, very problem. It's odorless. So if we use liquid nitrogen for cryogenic system, so our targets, our interest is it should not give any kinds of odor, because we from these kinds of food materials we want that it gives its own natural odor. Then non-corrosive, non-flammable. So these are unique properties of nitrogen that make it very good candidates for using in our food, cryogenic grinding and food processing industry. Even though not only in cryogenic grinding, liquid nitrogen or this nitrogen gas, due to these properties, we use for packaging purpose also. So this is extremely cold. Its boiling point is minus 195.8 degrees Celsius, and when we cool it, it appears like water. You can see it's just like water. It appears like water. Volume of expansion liquid to gas. So at 15 degrees Celsius and 1 atmospheric pressure. So if we take 1 liter of liquid nitrogen, it expands into 682 liters of nitrogen gas. So you can imagine how much volume it needs. So that is the reason we need a very good container in which we can store it. So this Divar flask we use for the storage of cryogen. So this the scientist by name Sir James Divar, 20, he born on 20 September 1942 and died in the year 27 March 1923. He was a Scottish chemist and physicist, and he has developed this container, cryogenic storage container. So it is having very good insulation. You see, this is they have developed this vacuum inside vacuum. So vacuum, no heat transfer, no conduction, no convection, and this is having silver surfaces. So that is why this container is quite expensive. So it has silver surfaces, hot or cold substance. We can use it for both hot or cold substance to store. Basically, our idea is to not having any kinds of heat gain or heat loss. So uh, storage content, liquid nitrogen or cryogen storage equipment was invented by Divar Flask. He was the first man who has liquefied hydrogen. Now, coming to the cryogenic grinding system. So this is also known as freezer milling or freezer grinding or cryo milling. So this is the act of cooling or chilling the material and then reducing it into a smaller particle size. So first we chill the material, we take away its all heat and then we grind it, and due to that, by that process, uh, we are able to get a good quality product, and due to the chilling it become brittle, so it take also less energy. And as we discussed in the Ayurveda and in medical fields also, like to make the powder of herbs, it can be used. So low temperature, very low temperature, sub-zero temperature, ranging from minus 18 to minus 57 degree also they can use it. So they can retain the all the phytochemicals which are there in the spice or herbs which are good for health. All the materials become imbrittle when they are exposed to low materials, so it becomes easy for grinding. It utilizes the cooling effect of liquid nitrogen to imbrittle materials prior to and during the grinding. So there are both the process we can do prior, before grinding, pre-cooling, pre-chilling, and then grinding, or during the grinding also we can supply the liquid nitrogen. Normal grinding process which do not use a cooling system can reach up to 93 degrees Celsius or 200 degree Fahrenheit, so very high temperature. So such a high temperature will lead to reduction in volatile content, component, heat sensitive constituents of the herbs and spice. So to overcome these problems, we come with the cryogenic grinding process, which does not damage or alter the chemical composition of the plant materials, and the materials which are elastic in nature, having low melting points, low combustion temperature, sensitive to oxygen. These kinds of material also we can easily grind in cryogenic grinding system. So there are several application has been given in literature, and we can see in the different industry they use this cryogenic grinding system. They use cryo grinding for steels, in metal industry, thermoplastic and thermoset. So in rubber industry they use it. They use also for adhesives and for waxes, for explosives, like in aerospace they use it, and particular application in spice industry that leads to our food processing sectors, and that we will be of interest and we'll discussing. So spices are most important constituents of our Indian food. All Indians we like very spicy food. We use lot of spice. We are blessed by the nature that we have so many different climatic conditions to adjust in India, and we produce a lot of spices. Like in Rajasthan, Ajmer side, we are arid zone, so lot of cumin, coriander. Whereas in Calicut, Kerala, very good condition for black pepper, turmeric growing. So like that. And if we go northeast, there are a lot of organic turmeric, lot of spices we produce. So we use these spices not only in our house, we use in these hotels, restaurants, and food processing industry. Not only that, we export lot of spice. So in history also it comes that the foreigners, from decades back, if goes we see the people used to come for spice trade. The spices, particularly like pepper, cinnamon, chili, ginger, cumin, nutmeg, clove, they have characteristic taste and aroma, and they have medicinal value, very important. So they give this taste and specific aroma to the food, then people like it, and they also give the health benefits. That is the reason that in these corona situations, people in their home they use a lot of kada and all, and in that they use a lot of spices. So these characteristics qualities are very important in terms of their spice values. So these qualities are inherently present due to the essential oils or volatile oils, and these volatile oils get affected the temperature when when we go beyond the 50 degrees Celsius. As we already discussed some of the problem, again we are discussing some of the problems with our conventional grinding process. One is loss of essential oil or volatile oil due to high temperature. So this applied energy, this get dissipated in the form of heat, and this produce more than 99% of wastage. So whatever the application of heat energy we do, energy goes as waste in the form of heat, noise, frictions. Only very less amount only we use for actually, other goes as waste. So uh, the temperature in the grinding zone rises more than 90 degrees Celsius, and which is the reason for loss of essential oils, who is having its boiling point near 50 degrees Celsius, and this leads to inferior quality of ground products. It reduces the quality of the product. Then clogging and gumming of the mills. So some of the spices discussed like nutmeg, cloves, cinnamon, ajwains that contain high levels of fats, and when we grind it and at the high temperature, it releases its oil so that clog the mills. Some of the spices like capsicum, chili, they have high moisture content, so that also can lead to the clogging or gumming problem. So due to this clogging and gumming, one is the problem in operation, and other problem is that it affects the quality of our products. So these high oil content materials or high moisture content materials will stick to the parts of the grinder when we use the conventional method. Oxidation and related degradation is the another problem due to this intimate cyclone effect of the air in the vicinity of the grinding zone. These aromatic substances in the material oxidized and they leads to rancidity, oxidative rancidity. Other reason is that this fresh and exposed surfaces. So when we do the grinding, we increase the surface area of that materials. Uh, because of size reduction, surface area get increased and more surface get exposed to the oxidation. So oxidation process become more. Now, to overcome this problem, this cryogenic grinding system for spice we are discussing now. So, the cryogenic grinding system consists of mainly two units. So, first is pre-cooling unit. So, this is before grinding cooling, and other is grinding unit. So, during the grinding, we can use. So, in pre-cooling, pre-cooler there is a device which we have arrangement of screw conveyor which is enclosed in properly insulated balers. You will see in the grinder system, and it have a system to introduce liquid nitrogen into the barrel. So we will be finding like this opening, from there we can apply the liquid nitrogen, which and then it will be having that spiral moving thing, so it will take the materials to the grinding zones. So when we apply this liquid nitrogen, it gives the refrigeration, the chilling and cooling effect to the system. The function of cryogenic pickler is to remove the heat from the materials before it into the grinders. So it consists of this screw conveyor assembly as we discussed, and it also have then air compressor. So this liquid nitrogen Divar system is attached to that, and then it's have this power transmission arrangement, and then control panels to reduce the temperature of seat below its brittle point. So when we apply or we do this pre-coolings, materials reaches to the freezing point where it become very cool, like minus 50, minus 120, like that, very low temperature. So it become brittle also, and this is like kind of present condition. The temperature of recooler and feed rate to the grinders are controlled to minimize the loss of quality of the final powders materials. Another good thing of this system is that it helps to reduce the power consumption. Consumption of liquid nitrogen and operating cost are important consideration because this liquid nitrogen is expensive, and for operation we need energy, that's also expensive. The liquid nitrogen losses can be minimized to great extent by proper consideration for design and insulation of the precoolers. So we should design properly so that the minimum loss of the materials is there. So there are different consideration, engineering consideration we have to take into consideration for the development of these kinds of grinders. First is retention time. So how much time accurately we need to do keep the materials in grinder. So that's the retention time. We have to optimize it. Then appropriate insulation. Grinders should have appropriate insulation so that it will not lose its heat to the surrounding ambient conditions. Then dismelting and cleaning should be easier. We should be able to easily open it and easy to clean it. Then cool down losses should be reduced by keeping the um, mechanism size and structural component to a minimum. So this is the unit. You can see here we apply the liquid nitrogen and then this the or pre-cooled materials or spice which is to be ground, and this is spiral structure. So it goes inside and it will stick to the grinding jar. So the operation of grinding was performed by impact and attrition forks, and this is operated by electric motors, maybe something like this we have. Then ground powder we can collect at the outlet. So we have a outlet arrangement where we can collect the ground powder. So this is a flow chart. So first we will be loading in the hopper through the vacuum container conveyor. So this kinds of hopper structure we have. Then we have feeding in cryogenic screw conveyor. So from hopper it will take taken to the screw conveyor. Then chilling our spice with liquid nitrogen. So from other side we apply the liquid nitrogen so that we do chilling. Then feeding our spice in the grinders, and then grinding our spices is done at low temperature and in a inert atmosphere, and then we bring it to the room temperature, and finally we do the packaging of the spices. So this is the system, a diagrams which shows how this. So we have this control console. So and then we have this liquid nitrogen tank here where liquid nitrogen is stored, and this liquid nitrogen is taken through these valves, and from this side we supply these spice materials which we want to grind it. So you can see these spices, and then we have these kinds of this screw conveyor which carries the materials to the grinding. So this is the grinder. So when we open the knob, we can supply liquid nitrogen. Liquid nitrogen come along with this, and here in this grinder, grinding takes place, and finally we get the ground powder. Now, what is the good advantage of this grinding techniques? So high retention of volatile oils due to lower operating temperature. These volatile essential oil we can retain to more to the original level. The prevention of oxidation and rancidity. The heat developed during the grinding will be absorbed by the liquid nitrogen and converted into vapor, and it get eliminated, and the possibility of oxidation is reduced. Then increased throughput and power saving due to usage of liquid nitrogen, materials become brittle and it needs less energy for the grinding. So we are able to save some power. Then finer size particles. We get very fine size particles because there is no clogging, no logging, and materials are brittle. Then reduction in microbial load. So by cooling with liquid nitrogen, some bacteria become dormant. So some bacteria they cannot survive at very low temperature, like minus 150 degrees Celsius. So these kinds of microbial load also we can control. Then possibility of fine grinding of difficult spices. So by use of low temperature, raw material become brittle, and it is easy to grind the fibers by shattering. Fibrous materials you can grind. Fibrous spices like ginger can be ground easily. Those fibrous materials difficult to grind, but when they become brittle, easy for the grinding, we can get converted to fine particle. Then high oil content spices like nutmeg, ajwain, we can also easily grind. We can also grind like green chilies, so there will be no pre-drying, and and also we will be able to retain them in its natural conditions. So if we compare the traditional grinding system and cryogenic grinding system, we see that the traditional system needs the heat is developed inside the grinding mill, and that heat will lead to loss of the quality of the spice. Whereas in cryogenic grinding system, the temperature is below 0 degrees Celsius, and the effect on the quality is less. So, in this uh, conventional or traditional grinding, there is a problems like blocking, gumming, so due to oily materials, so those problems is not there in this cryogenic grinding. So another challenge in traditional grinding is the high energy consumption, but here energy consumption is less. And traditional grinding, high capacity motors are required for grinding the materials, but here low capacity motor also one. So here control is difficult on particle size, but here we can control it nicely. So if somebody want to read it in details, they can refer this paper published in Advanced Powder Technology, Evaluation of Size Reduction and Power Requirement in Ambient and Cryogenically Ground Fenugreek Powder. So different types of calculation is made and how much power is required in different grinders, and also one can read in details. This is another paper in powder technology. So here the different grinder has been taken and how much they are taking power consumption for the particularly two spices fenugreek and black pepper has been discussed. So if somebody is interested, they can go and study in details. Here is another study in Journal of Food Process Engineering. The paper is published. So this paper particularly talk about the flow characterization of ambient and cryogenically ground black pepper powders. So how this conventionally ground powder and then cryogenically ground powders properties getting affected. So this is discussed on those papers. So somebody is interested can go through those papers. Now, there are some challenges or health hazard related with cryogenic liquid. So, skin and eye hazard. So, cryogens are extremely cold, as we discussed, with low temperature. They can cause instant severe frostbite or the problems to eyes. So when one is handling them, they should be taking proper care. They should use googles. They should put proper hand gloves and all. Then cold embrittlement at cryogenic temperature. Many materials such as rubber, plastic, carbon steel, they become so brittle that very little stress can break them. So this cold embrittlement needs to be taken care. Otherwise, it can be a hazards can be a problem. Then oxygen enrichment. When transferring liquid nitrogen through uninsulated metal pipes, the air surrounding a cryogenic condense system can condense. Nitrogen, which has lower boiling point than oxygen, will evaporate fast. This can leave an oxygen enriched condensate on the surface that can increase the combustibility or flammability of the materials near the system, and that can lead to a potentially explosive condition. So this should be avoided, this should be taken care, precautions should be taken care. So what the precaution we should take? So we should be familiar with the hazard associated with cryogen, particular cryogen, what kind of hazard is there. Now, work in open and well ventilated condition, we should be having proper ventilation, open space. We should always wear goggles, face shield, and appropriate gloves we should put on. Then we should examine the container and pressure relief valve for the sign of defects, and we should ensure that all the equipments container are free from the oils, grease, dirt, because these oils can be flammable materials, grease can be flammable materials, and it can be fire hazard. So we should take care. So conclusion is that as the prices of this energy and raw materials rise, the concerns for environment make the safest and costly. So the resources recovery become vital matter for today's business. It's very important to have minimum energy input and get the maximum output. Another concerns is quality of that material. So quality and cost. So this cryogenic grinding technology efficiently help us to grind the materials with having best quality, very near to the natural one. So it employs a cryogenic process to brittle and grind the materials to achieve the consistent particle size. As per our requirement, we get the particle size range. So this is a unique novel approach, and it's also have recycling. The wastage can be reduced. Like there's a problem with conventional grinders; it's create lot of dust, a lot of problems to the person who work in that area. So these are the different references one can go through. So here these are the student, PhD student who works in these fields. Uh, These are the MTech students of our university. With this, I conclude my talk here. Thank you very much for patiently hearing and time giving for this lecture.
It was really very wonderful lecture, Professor Meghwal. Uh, this is
Thank you. Thank you.
this has covered 360-degree because I can see, in my understanding, the cryogenic technology is mostly used in aviation industry. Uh,
Yes.
and predominantly it is being used in aviation industry, and you have brought live usage of that cryogenic in our day-to-day life, which you have very nicely explained, right from Lord Krishna, this small Krishna, who was tied up in one such thing, and till the advancement of this cryogenic tool, how it works for getting spices, and how it is worked in rural industry, how it is worked in large scale industry. It was really an inflow of huge, extensive work data which you have created, which is going to really immensely help entirely the
I, I
students.
have I have tried to pick up some of the most important information. Lot of work has been done and lot of research going on in this field also. So like phytochemicals which are very good for health. So our intention is to retain it. So a lot of work is going on in this field. It's have wide applications.
I see something different. Generally, when we see the participants, or generally when we see the kind of audience who are attending, will show the quality of the presentation or the work which is being done. There is a work done in research which is done in a professional manner, and there is something more to it, which is from core of heart, with full involvement in that kind of research work, and the passion shows the quality. So it is extremely fantastic presentation I have seen ever in my period, I can say, with whatever little knowledge I have. And really, truly, very commendable job, Dr. Murlidhar Meghwal. You have contributed to this TRI Center webinar series. It is really fantastic conclusion. Um Needless to say, there are a lot of questions which has come in. I think this day I don't want to ask questions. Generally, I ask questions. Uh, the questions, considering the time limits, we are going to the question answer sessions, Dr. Pandit and Meghwal. First thing has come from Captain Abshankar, our viewer. While extracting oil from the seed, outcome oil found to be in a higher temperature generally. Even in organic process, this is there. What is the role of temperature in oil retention in nutritional values? The temperature and the relevance between the retention of nutritional value.
So the like grinding, we do grinding like conventional grinding. So for example, we go outside atta chakki and we get the our flour done, and then when we touch it, we can feel how it is hot. So we cannot touch it. It's a very high temperature, like 90 degrees Celsius, and temperature when it goes beyond 50 degrees Celsius, it starts deteriorating the quality of the food materials. So the temperature plays a very important role. So when it goes high temperature, it will evaporate the important volatile oils. And volatile oils are the constituents which have a lot of flavor materials, flavoring compounds, very useful health benefiting compounds. So that will get maybe they get oxidized or that get a different form or they may get evaporated. So in that way, it will lose the nutritional value and the phytochemical profile health benefiting compounds get deteriorated.
Thank you, Dr. Murlidhar. This was really apt answer for the question, and the question was also great question. Now we have our great friend, our viewer, Mahalashmi. She has asked three questions rather, not one. Uh, does cryogenic grinding has bactericidal effects?
I am not able to hear what is that effect.
Bactericidal, Bactericidal, bactericidal.
Oh, that we discussed that some of the microbes that cannot survive at low temperature, very low temperature, they become dormant. So in that case, we can say that the microbiologically we are able to retain the good quality, preserve the good quality of the food material at the low temperature. Because when we in biology we see when we study that biological the low curve of microbes growth, so that dormant phase we are able to retain, or maybe some microbes they become inactive during that low temperature.
That's
But when we do grinding and then when materials come to the room temperature, then we have to store it properly. We have to pack it properly. We may use proper packing materials, inert materials, then aseptic packaging that we have to take care. Because we have done grinding at very low temperature, of course it will try to gain the moisture from surroundings, so that we have to take care.
Thank you, Dr. Murlidhar. Now the second question from Mahalashmi is, how is the use of LN2 and what is the impact in enhancing aromas and taste?
So liquid nitrogen, in nature we have 78% this gas only. So we have the in the cryogenic science, they have developed the equipment by which they cool this, they extract it, they separate it, then they bring it very low temperature, so it comes in the liquid form like water, and that gas we use for the grinding process. So when we use it for grinding, then it make the material brittle, so easy for grinding. And we discussed several other aspects already.
Yes, that was there. The question is really brilliant. Now the third question from Mahalashmi is, how do we eliminate the risk of mixing in of foreign objects, that is contamination, while grinding?
So that is the reason we have studied the properties of this gas. So we discussed that this gas is inert, this is odorless, tasteless, non toxic. So these are kind of unique property. Due to this property only, we are able to use this liquid nitrogen. So we will be using it for the grinding purpose. Then it will be getting evaporated, nothing left. Material will be in our its own natural color, natural taste, natural flavor only. So that is the reason if something is adding its color, it's adding its taste, flavor, then those kind of cryogen we cannot use, because every consumer is concerned for color, taste, flavor, aroma. They want its natural color, natural flavor, natural aroma. So this is very important. We while selecting the cryogen.
Now the last question comes from me. Professor Meghwal. I am unable to control myself. A visionary leader, Dr. J.C. Kumarappa, has found rural industries as a concept. The rural industry concept was very nicely explained by you, where you are looking at the oil gannies, you have shown it and the usage of it. Then the motorized thing which has come in. The usage in rural industries management, the usage of this liquid nitrogen is increasing nowadays. How do you see that this will help enhancing in output of this rural industries and the revenue model?
So this is very very useful, practical, application oriented, wonderful questions. Because liquid nitrogen is quite expensive, so how we can make it to application? It's to to up to the rural level. So this is a very important question. So see, if one side we see there is a lot of loss of due to not having proper processing, not having the retaining quality. So lot of the loss of our food material is there, particularly spice. So when we go for high quality, good quality spice, because we do lot of export of these spices. So at the rural level, if we put the small unit in which we can pre-cool and the minimum amount of liquid nitrogen we can use for grinding, then we can come up with very good quality spice, and that we can use for export purpose. We can use like five-star hotels, and they use very good quality materials that can be used. But yes, challenge is there, because production of this liquid nitrogen, it needs separate plant, and then it's expensive, it's container, it's retaining, bringing. So this is there. But I want to mention here that in Bangalore, the in a particular industrial area, I could not remember name, but they have started this plant. So there they use liquid nitrogen for the grinding purpose.
Thank you, Dr. Murlidhar. This is another question because you are not leaving me to leave this session. This is very interesting. What kind of role you see of this cryogenic grinding in cooperative industries? Because one is rural industry,
Uh,
one is cooperative industry. Like we have cooperative societies. They do also manufacture. They collect it from homes. How do you see the role of cryogenic grinding in cooperative societies?
so cooperative society, or you can say MNC, a lot of people are contacting and they're trying, but we say India is in this phase. They are establishing, coming with lot of more industries. So because if we see the processing of our food material is quite less, if we compare the developed countries, processing done is very high, our is less. So yes, our people, industry, the industrialist people, they are trying, they're coming with this, trying to overcome this challenge. So we see good future. In future, maybe we will be having the more processing, less is the loss is less, and we are able to, we will be retain the quality materials for longer time, with the best quality for export purpose, for our domestic purpose. We see good future.
Thank you, Dr. Murlidhar Meghwal. To sum up, you have touched. It is not only you have not given opportunity for anyone to ask questions. That is the kind of extensive
Thank,
coverage. That is the kind of
thank,
extensive coverage. But I
thank
really
you.
salute. I really appreciate the participation of Ravi, uh, Mahalakshmi. They have done. This is how the interest is created by you with the topic and with the facts which you have given. It was really very important, and it's like a textbook material at any given point in time for students from all walks, like rural industries management department or management department, or even your home science or food science. You can say anything. it is very relevant at this point in time, and I am sure this webinar is going to reach more people in the days to come to watch in YouTube. Probably the people those who have come, those who are watching will subscribe and get their enhancement in this kind of knowledge enhancement in this, enrich themselves with more and more lectures from very, very eminent people like you, sir. I'm really thankful to you for taking out your valuable time from your busy schedule to join us in this webinar session. Formally, I have to close this webinar. There are many people who have asked in this webinar, during this webinar itself, to give you a PPT, which is on very high demand amongst the student fraternity. I'm sure we'll do something. We'll speak to Professor to get it done.
No problem. If anybody interested, they can send me email. My email is their institute website. Anybody anytime can contact. I'm there to help them and guide them.
So this is the message what is being given by Professor Murlidhar Meghwal, that please do visit NEFTM website, see his email ID, and please write to him. In future also, whatsoever you have in your mind, the questions in your mind, the questions are more. We are unable to cope up with these questions because of the time constraints. I have to go for a formal closure. Let me acknowledge Dr. Murlidhar Meghwal has joined us in this webinar series, 9th webinar series on 4th day, and he has delivered a very, very important lecture in a topic, cryogenic grinding of spices, a novel approach over traditional grinding techniques. I thank you very much, Dr. Murlidhar Meghwal. I thank you all the viewers who have participated. I pray to God Almighty that you all should stay healthy, stay safe. Thank you so much, sir. Thank you from Gandhi Road Institute, DMTP University. Jai Hind. Jai Hind.
Thank you very much, Professor Sundar Pandyan. Thank you very much, Dr. S.P. Krishna Kumar, and I am very much thankful to the Gandhigram Rural Institute for giving this opportunity, and I hope we will be doing a lot of collaborative activities. Thank you very much for giving this opportunity.
Sure, sir. It is now our next turn will not be in webinar, we will be taken directly to Gandhigram Rural Institute.
Thank you.
Thank you so much, sir. You're most welcome to visit us in this. Let this pandemic get over, and we will invite you officially to come down to Gandhigram Rural Institute, enrich our students, and be with our staff fraternity. Thank you so much, sir. Thank you very much.
Thank you. Thank you.